In this video, let us look at the condition which ensures that the equation of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of lines. So represents a pair of lines if it represents a pair of lines if the condition is determinant of AHG HBF GFC is equal to 0. So this is the statement which you need to remember. So this expression is equal to 0 represents a pair of lines if this determinant is equal to 0. And this determinant can be very easily remembered. So first AHG, just look at the terms which contains x. So x is present with A, with H, with G. So the first row contains AHG. And the second row contains the terms containing y. So y is present with H, with B, with F. So H, B, F in the second row. And the last three terms are nothing but the last three terms GFC. So if this determinant is equal to 0, then this represents a pair of lines, otherwise not a pair of lines. So how did we get this condition? So if you remember, we have also derived this condition in our chapter of quadratic equations, right? So let me redo the derivation. Again, this derivation is not required for JEE mains. So if you are interested in the derivation, then go forward. Otherwise, you can skip this video right now. So as we have already seen, how do we factorize this? So we factorize this by assuming that this is a quadratic in x. So ax square plus x times 2hy plus 2g plus by square plus 2fy plus c is equal to 0. So x is equal to minus 2 times hy plus g plus minus root of b square 4 times hy plus g whole square, b square minus 4a times by square plus 2fy plus c divided by 2a. So this is the value of x. So if x has to be a linear function of y, that means if this has to be able to be separated into two factors, then x has to be a linear of y. So this has to be a perfect square. This expression in y has to be a perfect square. We have discussed in the previous question also. If the expression inside the square root is a perfect square, then square root gets eliminated and you get x as a linear of y. Now this 4 and this 4 becomes 2 outside. The remaining expression is, as you can see, h square y square minus ab y square. So h square minus ab times y square, h square y square minus ab y square. Next, 2ghy minus 2afy. This with y you have 2gh minus 2af, that is the coefficient of y. What is the constant term? Plus g square minus ac. So this is the expression inside the square root. So when will a quadratic expression be a perfect square? If the quadratic expression has to be a perfect square, then the discriminant of this expression has to be equal to 0. That means if this has to be a perfect square, I should be able to write this as some k times x minus alpha whole square. That means both the roots have to be same. If this is a perfect square, then it means it should be able to be written as x minus alpha whole square So this has to have repeated roots. This has to have repeated roots. So that means the discriminant of this expression has to be equal to 0. And also this coefficient of y square has to be positive, because this k is nothing but h square minus ab. As we have seen, ax square plus bx plus c can be written as a times x minus alpha times x minus beta. So the condition for this to be a perfect square is, first, h square minus ab has to be positive, and the discriminant of this has to be equal to 0. That is 4 times gh minus af whole square minus 4 times g square minus ac times h square minus ab has to be equal to 0. So if you expand this, you get some condition in terms of GFC ABC. That condition is exactly same as this condition. So if you simplify this, you get some condition. If you simplify this, you get exactly the same condition. Hence, this equal to 0 makes this a pair of lines. And you have to remember, h square minus ab has to be also greater than 0 for this to be able to be factorized into two factors. So if this is equal to 0 and h square minus ab is positive or greater than 0. Next, if you look at the homogeneous equation, that is the small equation. So if you have ax square plus 2hxy plus by square is equal to 0. So if you have this equation, what can you say about this equation? So if you compare this equation with this equation, the difference between these two is simply that g, f and c, all these three are 0 for this equation. So if g, f, c is equal to 0 in this equation, so as you can see, this determinant's third row is completely becoming 0. So this determinant will automatically be equal to 0. So if I call this delta, for this homogeneous equation, delta is automatically equal to 0. This implies the homogeneous equation always represents a pair of lines. And if h square minus ab is greater than 0, h square minus ab is greater than 0. h square minus ab is greater than 0. As you can see, GFC is already equal to 0. So this term is 0, this term is 0, G is 0, C is 0. So all these terms, so I have written the expression that you have got inside the square root. So for this expression, for homogeneous expression, so this and this has become 0. So if h square minus ab is greater than 0, the root of this will be nicely obtained outside. Root of this will be a linear in y. So h square minus ab is greater than 0. You get two distinct lines through origin. As we have seen, the small equation comes if both the lines pass through origin. And if h square minus ab is equal to 0. So if h square minus ab is equal to 0, so this term also has become 0. So inside the square root, there is nothing left. So x is equal to minus b by a plus or minus 0. That means both lines have coincided. So coincident lines. And if h square minus ab is less than 0, so these two terms are automatically 0. You get minus of some number times y square. For example, you get minus 3y square inside the square root. Obviously, this is an imaginary quantity, so you won't get real lines. So I say that they are imaginary pair of lines. That is, effectively there are no pair of lines, but that equation looks like a pair of lines. So I say that they represent imaginary pair of lines. So I hope you have understood the analysis of the general quadratic in x and y and a homogeneous quadratic in x and y. So the general quadratic in x and y represents a pair of lines if these conditions are valid. A homogeneous equation in x and y, a homogeneous quadratic, is always a pair of lines. If h square greater than ab, they represent two distinct lines. H square is equal to ab, they represent coincident lines, and h square minus ab less than 0, they represent imaginary pair of lines. Remember, imaginary pair of lines means that there are no pair of lines, because inside the square root you get something like minus 3y square or something. So you get an I with y. That is not a pair of lines. That is not a line. So now let us go forward.